Hello everyone. Uh, Today we will discuss a very important topic in solid mechanics, and the topic name is analysis of perfect frame. This perfect frame, also known as plane truss. The plane truss member and frame member are different. In frame structure, the joint of the member, the joint between the two members are rigid joint, but in truss member the joint between the two members are not rigid. They are considered as hinge joint. So as the joint of the two members are considered as hinge joint, so from one member to another member only force can be transmitted. No moment can be transferred from one member to another member. But in case of frame structure, from one member to another member, force as well as moment can also be transferred. So the frame structure are shown in various civil engineering structure like railway bridge, in stadium, in workshop shed, and so on. So there are two type of truss frame are there. One is called perfect frame and another is called imperfect frame. So according their arrangement and number of members, this member is called as perfect frame member, and another type of frame member or truss member is called imperfect frame member. So those member which will satisfy this equation is called perfect frame. In perfect frame, n must be equals to 2j minus 3, means number of joint, number of member is equals to 2 into number of joint minus 3. So if we consider this is a frame structure or this is a 2D frame, so n must be 2j minus 3. So if we consider n is number of member, so here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 number of members are there. So 13 equals to, now we count the joint. The joint is 1, 2, 3, 4, 5, 6, 7, 8. So 13 equals to 8 into 2. So 8 into 2 equals to 16. So 16 minus 3 equals to 13. So 13 equals to 13. So this equation is satisfied for this particular frame structure or truss structure. So this type of truss structure, 2D structure, truss structure is called as perfect frame. If this is not satisfied, if this equation is not satisfied, then this truss structure is called as imperfect frame. Here, this is also a simple type of frame structure or truss structure where number of members is 1, 2, 3. So n is 3 equals to joint is 1, 2, 3. So joint is 3. So 3 equals to 2 into 3. 2 into 3 equals to 6. 6 minus 3 equals to 3. So 3 equals to 3. So this is also a example of perfect frame. Now in truss member, as we see, force can only applied at the joint of the member. So A is a joint, B is a joint, C is a joint, D also a joint, and E also a joint. So force can only apply to the joint of the member. Force cannot be applied to the middle of the member. So force cannot be applied to the middle of the member. So when we analyze or when we go through the truss structure, we always apply the load at the joint of the truss member, and A and E is the support of the truss element or truss structure, and in support always there should be a resistance. So an A and E, a resistive force always be applied in each and every type of truss member. May or may not be in all joint having any force or not. Means here you can see in all the joints there are some type of forces applied, but there are some cases also be there where some few joints having a load and a few joints having no load, and this is also will happen in analysis of truss member. So next we will go through the imperfect frame. As we discussed earlier, in imperfect frame, number of joint number of n cannot be equals to 2j minus 3. So this equation cannot be equal for imperfect frame. So in imperfect frame there is two type of frame are considered. One is deficient frame and another is redundant frame. So what is deficient frame? A deficient frame is a frame is a imperfect frame in which number of member are less than number of member is less than this 2j minus 3. So where n n is less than where n is less than 2j minus 3, this is called n is less than 2j minus 3, then it is called deficient frame. So what is the example of deficient frame? So if this is a truss member and here is the support of the truss member, here is the support of the truss member. So for this type of truss member, if we find the number of member is 1, this is 2, this is 3, and this is 4. So n equals to 4 and number of joint equals to the number of joint equals to 1, 2, 3, 4. Number of joint equals to 2 into 4 minus 3. So 2 into 4, 8. 8 minus 3 is 5. So 5. So this product is 5. 5 is less than 4. Sorry, 5 is greater than 4. So this type of truss member is called as deficient frame. So what is redundant frame? So redundant frame is completely reverse. Means if the number of member is more than 2j minus 3, means the required member is more the required member is higher compared to 2j minus 3. So this type of frame is called redundant frame. This type of frame is more stable because the number of member is more in this type of truss member or truss frame. So here if we consider this frame. So in this frame, number of member is 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11. So here number of member is 11. So 11 equals to, or 11, or here we can count the number of joint. So number of joint is 1, 2, 3, 4, 5, 6. So 2 into 6. 2 into 6 means 2 into 6. 2 into 6 minus 3. 2 into 6 minus 3. So this product is 12 minus 3, 9. So 11 is greater than 9. 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 So this type of truss member is called as redundant truss or redundant frame structure. Now here one question will arise, that why we can't consider this joint and this joint. So as we consider this is a whole member, that's why we does not consider this is a joint. If we consider this one is this member and another is this member, then we consider this one as a joint, and that case also, and that case also, okay, and that case also the answer will be same. Now we can go to this one. Now if we consider this one, so and that case that case we can having extra 4 members. So here we can getting extra 2 member, and here we can getting extra 2 member, and this case will getting number of member equals to 15. So 15. Why 15? In previous case it was 11, but now we can getting extra 2 member. So here it will divide it into, here we previously we can consider this is 1 member, now it is considered as 2 member, and here also we can consider this is a 2 member. So in this portion we will getting 2 extra member, and in this portion we will getting total 4 number. Previously we consider 2 member, and that's why we will getting extra 2 member. So 2 plus 2 4. So previously it was 11, now it is 15. So now we'll consider number of joint. Number of joint is 1, 2, 3, 4, 5, 6, and now we have to consider this one 6, 7, and 8. So 2 into 8, 2 into 8 is 16 minus 3. 16 minus 3. So 16 minus 3 is 13. That case also 15 is greater than 13. So in this process it will also be a redundant frame. Okay, so in redundant frame always member, number of member is greater than number of member is greater than this equation 2j minus 3. Okay, so in our courses, deficient frame and redundant frame is not there. We in solid mechanics we have only the perfect frame portion, and perfect frame can be analyzed in two methods. Later on we will discuss these two methods, and with this help of these two methods we can easily calculate any type of perfect frame with very minimal time. Now those who are not habituated in this type of support condition, I will discuss this one. So this support is considered as hinge support, and this support is considered as roller support. In hinge support there are two reaction forces is there. One is vertically upward and another is horizontal force, and this roller support only one reaction force is there. This one is up in upward direction. As roller, you can see this is roller. So if we uh, apply the force, we will easily move in horizontal direction. So in roller support only one reaction force is there. Reaction force is only having in this position that where resistance will occur. So this due to this support, the frame cannot move downwards. So this is also applicable for this roller support. This all this for this support, this frame cannot be uh, moved in downward. That's why it will create some resistive force. That's why this resistance or reaction force that is occurred. So this reaction force calculation also be a important part to analyze this type of truss member. Here also one redundant frame is there. Here we can calculate easily. So if we go through this in very uh, quick time, we can see that total number of member is 1 2 3 4 5 6 7 8 8 total member, and number of reaction is number of joint is 1 2 3 4 5 6. So 6 into 2 12, 12 minus 3, 12 minus 3 is sorry 1 2 3 4 5 6. 6 into 2 12, 12 minus 3 is 9. So 9 1 1 2 3 4 5 6. One mistake will be there. So total number of member is 1 2 3 4 5 6 7 8 9 10. The total number of member is here is 10. Here is 10. We'll count again 1 2 3 4 5 6 7 8 9 10. And number of joint is 1 2 3 4 5 6. 6 into 2 12, 12 minus 3 is 9. So 9 is less than 12, less than 10. So this is also called as redundant frame. So thank you. This much portion is considered as a uh, type of truss member, type of frame member, and how we can determine this is a perfect frame or imperfect frame, and so on.